Good morning, class. As you may obviously know, I'm not there. So please watch this video and pause wherever necessary. Today's goal is to do, we're learning two new things. But I'm going to show you guys a very quick, easy way to do them so the notes don't feel as long. So the first part should look like this. And this is, the most important part here is just knowing that roots, excuse me, zeros, x-intercept, and solutions are the same thing. A lot of us are still having trouble remembering that, but there's just no other easier way to make this topic, y'all. Y'all have to know that zeros and x-intercepts are the same thing. So finding your zeros here, we have x equal -2 and x equal 1. You could also call it 1, 0 or -2, 0. So I'm going to skip through here and just go ahead and flip to the back to the good stuff. Now, this would be what we would do normally, and it is a lot and can be very overwhelming. So we're going to shortcut this. And I want you guys to go to the next page. This is the type of star problems they would give you. So the graph of a quadratic function is shown on the grid. Write a function in standard form that is best represented by the graph. Keyword here, best represented. All this question really wants you to do is find one of these equations, A, B, C, or D, that matches what they gave you. So let's not make this more complicated than it needs to be. The only key part here is finding 3 points that match. So the easiest points that we want to look for when we start graphing these on Desmos are your zeros. So here we have 1 and 5. Vertex is also a good indicator. So your vertex here is 3, -8. And sometimes you have y-intercept. So the y-intercept here would be y equal 10. So if we can have any of these match on Desmos when we start graphing these, that is our answer. So if you don't have Desmos opened up already, go ahead and pause and open it up. I'm going to go ahead and start typing in A, answer choice A, to see if it works out. So I have a graph. It almost looks similar, but let's just double check and make sure this is the right answer by clicking on those important points. So don't be scared to click on it on Desmos. It will hold it for you. That way you can see all of the points, not just 2, 3. You want at least 3, and I should have mentioned that earlier. You want at least 3 points that match. The more the better, but you only need 3. So looks like the x-intercepts match. The vertex and the y-intercept are not it though. So that lets us know that A is not my answer. So let's go ahead and try B. And hopefully this is our answer. I do suggest you guys are following along with these, or at least paying close attention so you know exactly what to do. So here our y-intercept 0, 10, okay, check. 1, 0, check. 5, 0, check. And vertex 3, -8. That is a perfect match. Our answer is B. Don't even have to test the other ones out. Very good. So let's try a different one. These you guys tend to struggle with because they only give you part of the quadrant, so only part of the graph. And it can be tricky sometimes if you're not being careful. But it's the same steps, y'all. Find your x-intercept. Here looks like at the origin, so 0, and x equal 2. Then the y-intercept is not as obvious, but you guys should hopefully know that the y-intercept is also coming from the origin. Y equals 0 in this case. But if that one if you were not able to find that one right away, you still have the vertex here. And the vertex here is 1, 16. So now let's go ahead and start testing some of these out. So once again, I'm starting with A. And I want to make sure I check these. So click on them on Desmos. Don't be scared to click on it. It looks like our vertex is a good match. And one of our x-intercepts is also a good match. but that's only 2 points. The third point here is negative 2 comma 0, and that unfortunately does not match. So for that reason, A is not our answer. So let's go ahead and test out the next one. Negative 16x squared plus 32x plus 32. Let me hide the other one. If you have to zoom out, what I recommend is that you guys zoom out to where you can see the pointy parts of the vertex and the zeros, or the y-intercept if that's the case. So looking at this one, it looks definitely off, so B is not it. So hopefully our answer is C. So f of x equal negative 16x squared plus 32x. All right, looks like it's a little bit better. Let's double check 3 points. That looks like a match. And our answer is C. So what I suggest you guys do right now, pause the video and go ahead and work on slides, what was it? Slides 13 through 18. Very similar to these problems. See if you got it down. And if you do, come back to this. And we'll go on to the next and last part. All right, so the last part here is transformations. It's a different topic from what we just did. These are also kind of fun, and also make these as sweet and short as possible. So the most important part for this is knowing the quadratic pairing function, the OG, the original. When we're talking about transformations is really just change. We're just changing from something to something else, something new, right? So I want you guys to circle f of x equal x squared. This is so important that you guys memorize. You have to memorize it. Knowing that that is the parent function is how we're going to figure out these problems. I will go over these in a little bit more detail on the next page. So I'm going to skip around, but we're starting with example 1. At this time, I do suggest you have your decimal screen opened up because this is very visual. So having a visual here is going to help out tremendously. So the graph of f is transformed to create the graph of g of x equal x plus 4 squared. Now, that looks weird reading it off, but the key word here is transformed. So we know that f, the OG, original, changed to create g of x. This is the new. When you guys see g of x, usually that's your new. So we want to describe that change. So let's type in our original, f of x equal x squared. Should go something like this, and the original will always pass through the origin, through 0, 0. So this is our original, and we want to see what happened to it when it became g of x. All right, so we went from red to blue. Also, pro tip, if you press and hold on the little red squiggly on decimals, you can change the color and change it to like a dashed or dotted line. It makes it a little bit easier to read. So we have these two graphs, and we just want to describe it. So don't overcomplicate it more than it needs to, y'all. Click on the vertex, so click on the pointy parts on your decimal screen. So for me, it was 0, 0, and then negative 4, 0. That usually helps you out to figure out what's happening to the graph. So the big descriptors we're using here is up, down, left and right. So are we moving to up, down, right, left, from the orange to the blue? Well, hopefully you said to the left. We're moving to the left. How many units? 4. We're moving to the left 4 units. And then that's it. We're just describing the movement. So let's try a couple more. That way we can kind of get the feel for these. So number 3, or example 3 says, the graph of f was transformed to create this new graph. G of x equal x squared minus 5. So again, click on the vertex, y'all. Don't be scared to click on it. That's going to help you out. From orange to green, What is the descriptor we're using? Up, down, left, right. Hopefully you said down. Down how many units? 5 units. We went 5 units down. Good. Now let's do number 5. Let's do number 5. Notice I'm not deleting the parent function because I need the parent function every single time. So g of x is equal to f of x. Also, I'm doing number 5, if I didn't say that already. So here we're going from orange to purple. Click on the vertex. Don't be scared to click on it. I'm over here clicking on everything. Okay. 0, 0, and then 0, negative 4. Describe the change. We went down, how much? 4 units. And that's it. So one last one on example 8. The graph of f was transformed to create this new function, g of x, equal x minus 1 squared plus 9. All right, okay, so we have a little bit more fancy here. So let's see. From the orange, the OG, to the blue, click on the vertex. Continue clicking on the vertex. What happened? Now, this one is not straight up and down, left and right. But you know it did go up, and then it also moved to the right. So we're just going to use 2 descriptors here. So we went up how much? 9 units. We're going up and down, y'all. That's the y-axis. And then we move to the right 1 unit. That's, if we're moving left to right, that's your x. And this is your y. And we're done. We described the descriptor. When you guys are doing your decimal screen, and I would actually pause the video and do slides 22 to 31. They're exactly like this. You're going to see horizontal and vertical shift. Horizontal just means left and right. And vertical means up and down. Or maybe I should have done them different colors. So, go ahead and try those. Pause the video and then come back. All right, so hopefully we're back. The last piece of information for today is still the same topic. It's just a different approach. You guys could do this knowing what you do know, but I'm going to show you guys an easier way to do these. So now we're working kind of backwards. They're giving us the description. So they're telling us this changed or translated 7 units to the right to create the new graph. Write the function, write the new equation. So now we're writing the equation. So because we are writing a new equation, we need to start with g of x. This is new. And our skeleton, so kind of our layout, should look something like this. Or it could look like this. So the way we know which way we're writing that is by first reading, are we moving to the right or left or up and down? Well, we're moving to the right, right? They want us to move to the right. So if we're making a change from right or left, we know we have to stay inside the parentheses. So our layout's going to look like that. Now, intuitively speaking, if I said move to the right, do you think that's a +7 or -7? Just intuitively, you would probably think +7. I would too. But with moving to the left and right, we have to think opposite sign. So even though we think +7, do the opposite. And do -7. So that is what goes into our new function. So let's try a different one. That way you guys can see. The graph of f, so number 2, the graph of f translated 2 units to the left. So intuitively we are thinking probably -2, but we have to do opposite. So +2. To create the new graph, so g of x, we're moving left to right, so we're inside the parentheses. and we are moving to the left, so plus 2. All right. That one's probably the trickiest part in this section, but luckily for us, up and down is very intuitive. So looking at number 3, the graph of f is translated 4.5 units down to create the new graph. So this is exactly what you would think it is. If we are thinking down, we are going down 4.5. So minus. This is exactly what you would think. Now, because we're moving up and down, the minus 4.5 is not going to be inside the parentheses. This is going to be outside the parentheses. So it will look like that. And that is our new function. So let's try an up. Number 4, the graph of f is translated 4 units up to create the graph of g. So our new graph, we're moving up and down. So we know we're outside the parentheses, and it's exactly what you would think, so plus 4. All right. So I try to summarize that as best as I could. As you guys can hear, the bell went off. So try these. These are slides 32 to 41. They're self-checking, so you know you did them right if you get a big check. And that's it, y'all. Have a good weekend. I'll be back Tuesday, so if you have any questions, let me know then. Bye now.